Water, a chemical that is essential for life and something that we encounter every day of our lives. But because of that ubiquity, it is very easy for us to fall for misinformation and find ourselves believing in claims that aren't actually true. Hello, and welcome to the Chemist's Codex. My name is Peter. I like to talk about chemistry and movies and TV shows and Dungeons and Dragons and whatever else might catch my interest. So, if any of that sounds interesting, make sure you hit that subscribe button so you don't miss my next video. Now, we all know what water is. Like I said, it's essential for life. But it is very easy for people to exploit gaps in our knowledge to sell a product or spread misinformation. For this video, I want to go through some claims about water and water related products, mainly pointing out the misinformation and half truths that are present. Before I get into those claims, though, I want to give some basic information about water as a chemical. We should all be familiar that water has the chemical formula of H2O, meaning it has two hydrogen atoms bound to a central oxygen atom. It has a bent shape due to the lone pairs of electrons on that central oxygen atom, and this helps make the molecule polar, along with the large electronegativity difference between oxygen and hydrogen. This polarity allows water to dissolve a wide variety of things, including many vitamins and minerals that are essential for our body to function. This large electronegativity difference between oxygen and hydrogen also allows the molecule to exhibit something called hydrogen bonding, where the hydrogen atom of one molecule can make a sort of pseudo chemical bond to a lone pair of electrons on another molecule. And this is why water is wet. You have one water molecule on another water molecule. Sure, if you have a single molecule, it's not wet. But the second you add a second one in there, water is wet. Now, the first sort of claim or group of claims that I want to go over is involving total dissolved solids, or TDS. This is pretty much what the name implies. It's a measure of the amount of stuff that's dissolved in water. The only thing is that people can misunderstand what this measurement actually means, and a lot of water filter products will advertise zero TDS or low TDS in order to sell their products. You can also purchase handheld TDS meters online, and I've seen people on social media using these and then freaking out over how high the number is, and they don't really understand what that number actually means. There are also some water filter companies, such as Zero Water, that market their filters as removing all total dissolved solids. The important thing that seems to be missing from conversations around total dissolved solids is units. People will just give a number, but without units, it's meaningless. So, what does a TDS reading of 250 actually mean? Well, in this instance, it's a measure of total concentration. But concentration can be measured a lot of different ways. In the case of TDS, it is a measure of parts per million, or milligrams per liter. So, for that number of 250, there would be 250 milligrams of stuff dissolved in 1 liter of water. And for a typical glass of water, that would be half that amount, roughly speaking. And it's also important to remember that this is a total concentration, and we're dealing with milligrams of material. So when you take both of those into account, there's not really a whole lot of anything all that specific in a glass of water. Additionally, you actually do want some stuff dissolved in your water. Obviously, nothing harmful like lead or bacteria, but we need vitamins and minerals, and water is a good way to get that. Minerals like calcium and magnesium iron all play important roles in our bodies. And while it's possible to get those minerals from a balanced diet, our bodies can much more readily absorb them when they're found in water. And when you add up the concentrations of all those minerals in a glass of water, the TDS comes out to be around 200. And a TDS reading of around 200 is still good quality drinking water. In fact, it's actually pretty good. In most cases, it's usually around a TDS of 500 when water stops being safe to drink. And most tap water will have a reading somewhere between 200 and 400. So if you're one of the people who carries around a little TDS meter to check your water wherever you go, you don't need to freak out unless it's over 500. Talking about total dissolved solids actually segues nicely into the next topic I want to talk about: alkaline water. Alkaline water seems to be fairly popular with its packaging boasting that it has a pH of 9.5 or something of the like, but I feel like people don't really understand what that means. I'll get into how TDS relates to alkaline water in just a moment, but before I do, I want to give some information about acids, bases, and pH. First, what's an acid and what's a base? There are a few different definitions, but the one that I'm going to be using for the purposes of this video is the Bronsted-Lowry definition. This defines an acid as anything that generates a hydrogen ion or a proton in water, and a base as anything that generates a hydroxide ion in water. pH is then a measure of the concentration of hydrogen ions in solution. There are a few different explanations for what pH actually means. One of the most common ones that I've seen, and my personal favorite, is that it means power of hydrogen. Although mathematically, pH is defined as the negative logarithm of the hydrogen ion concentration. This means that pH is also a logarithmic scale. So, in order to change the pH unit by 1, you would need to either increase or decrease the concentration of hydrogen ions by an entire order of magnitude. We define something with a pH of 7 as being neutral, since that's the pH of pure water. Water has a pH of 7 because it undergoes something called autoionization, where it will spontaneously break apart into hydrogen ions and hydroxide ions. This gives water a hydrogen ion concentration of 1 times 10 to the negative 7th moles per liter. Anything with a pH less than 7 we refer to as acidic. Anything with a pH higher than 7 we refer to as basic or alkaline. So, alkaline water has a pH around 9, depending on the exact brand that you get. This is achieved by adding things like calcium or magnesium. So, alkaline water should have a reasonably high TDS reading, typically closer to something like mineral water than tap water. But what does alkaline water actually do? Well, there are several completely unreasonable claims as to what it can do, such as preventing diseases or changing the pH of your blood. The only reasonable claim that I've seen alkaline water given is that it can help with acid reflux. However, it's important to note that stomach acid has a pH of around 2. So any alkaline water that you drink is going to be instantly neutralized the second it reaches your stomach. And frankly, you could have an equally effective result if you just mix some baking soda in with a glass of water. If you're trying to deal with acid reflux or heartburn, it's probably better to take a typical antacid like Tums or Alka-Seltzer. I also want to bring up something that I'm not sure the general public is entirely aware of. I mentioned earlier that some people might try to use alkaline water to change the pH of their blood, not realizing that our blood is kept at a very specific pH, and trying to change it would be practically impossible. You would have to drink enough alkaline water that you would probably suffer from water toxicity before you even change the pH of your blood. This is due to something called a buffer. Buffers are used to keep a solution at a specific pH and resist changes to that pH. I'm not going to get into all the intricate details about how buffers work because that would involve explaining a lot of different concepts, and this is supposed to be a video about water, not a chemistry lecture. So I'm just going to say that the important thing to note about buffers is that they are comprised of a weak acid and its conjugate base. Now, what do I mean by weak acid and conjugate base? Well, a weak acid is just an acid that doesn't fully ionize in water, and a conjugate base is just the acid minus a hydrogen atom. So if you combine a weak acid with its conjugate base in solution, it will form an equilibrium system to create a buffer. In the case of human blood, our blood buffer system is comprised of carbonic acid, H2CO3, and bicarbonate ions, HCO3-. So if you were trying to meaningfully change the pH of your blood through drinking alkaline water, you would need to drink enough to use up the buffer in your system. And like I said before, this would require an amount that by the time you reach that point, you would be suffering several negative effects from things like water toxicity or an abundance of minerals like potassium or magnesium. Ultimately, you can't meaningfully change the pH of your blood, and you don't even want to. Now, another bit of marketing that I've seen used for alkaline water is talking about electrolytes. And I feel like people don't really understand what electrolytes are. We're told that electrolytes help with hydration, which is true, but just because something contains electrolytes doesn't mean it's inherently better than something that doesn't. People talk about electrolytes like they're selling Brondo.
But Brondo's got what plants crave.
It's got electrolytes.
So what is an electrolyte? Well, in short, an electrolyte is just a charged particle or something that has the capacity to create a charged particle when dissolved in water. This is why water is said to conduct electricity. Pure deionized water actually isn't that conductive, but when we add an electrolyte into water, those charged ions can facilitate the movement of electrons. Some common electrolytes can actually be found in your kitchen. Things like table salt, baking soda, or vinegar, those are all electrolytes. Table salt is just sodium chloride, baking soda is sodium bicarbonate, and vinegar is just a dilute solution of acetic acid. All of these are electrolytes, and in fact, pickle juice would actually be a good source of electrolytes since it's just mainly salt and vinegar. So, what electrolytes do we actually need? Well, sodium and potassium are some main ones that people talk about, but things like calcium, magnesium, and bicarbonate are also important electrolytes that we'll need in our system. However, when talking about electrolytes, people tend to be talking about hydration and exercise, and in that instance, the main electrolyte to talk about is sodium. Sodium is used to regulate hydration by making sure our cells and tissues can actually absorb the water that we drink. And sodium is lost through sweat, which is why people talk a lot about replenishing electrolytes when they're exercising or doing some other activity that leads to an increased amount of sweating. However, there are some drinks that can be misleading with their electrolyte content. Alkaline water is actually a good example of this. Many alkaline water brands will advertise their drinks as having electrolytes, but most of them only add sodium to improve the taste of their water since alkaline things tend to taste bitter. And there's not even enough sodium to really matter in replenishing electrolytes, usually only like a couple dozen milligrams. So let's talk about sports drinks. Something like Gatorade or Powerade do contain a good amount of sodium, usually a couple hundred milligrams, which makes them helpful when replenishing electrolytes when you're sweating. And something like Liquid IV contains 500 milligrams of sodium, which makes it the highest sodium content drink that I've been able to find. But I want to pay some special attention to Prime, specifically the sports drink Prime Hydration. Prime likes to boast that their sports drink has more electrolytes than other brands, and this is technically true. A normal Prime Hydration contains around 800 milligrams of electrolytes, which is a significant amount. But this is primarily potassium, which isn't going to help with hydration, and too much potassium can actually damage your kidneys. This goes to emphasize my point that just because something contains electrolytes doesn't mean it's better than something that doesn't. What's more important is the amount and specific type of electrolyte that you're getting. So after a workout, if you're feeling thirsty and want to replenish your electrolytes, try to find something with a few hundred milligrams of sodium instead. So that pretty much wraps up everything I wanted to talk about involving water, and this is by no means a comprehensive list of all the things that people don't understand about it. In fact, I want to go over a couple quick little things that I've seen that are just kind of crazy and don't really warrant a full discussion on. Now, I've heard of something called micronized water. I haven't seen any products relating to it, and I think that's because this is a bit of an older trend that has since died out because it just doesn't make any sense. The idea of micronized water is that you take a water molecule and you make it smaller. How does that work? I don't know. According to claims I've seen, it's breaking the water molecule apart, but at that point, it's no longer water, it's hydrogen and oxygen gas. So, micronized water doesn't make any sense whatsoever. Another thing I've seen that kind of baffles me is the idea that microwaving water will change the crystal structure of ice when you freeze it. I've found this one blog post, I can't even remember where, but it was talking about how microwaving water will negatively affect the crystal structure in a similar way to if you were to play some of Hitler's speeches through the water. I don't know where that idea comes from. It's insane and doesn't make any sense. And with that, now I really am done. Those last couple of points were just something fun to laugh at, not really super serious because they're so insane and nonsensical that I'm not going to take them seriously. And I'm hoping that through this video, if you've made it this far, you will start to think more critically about claims involving water or the stuff that we put in water. And so if you made it to the end of this video, thank you so much for watching. I appreciate your time and attention. I really do. Don't forget to subscribe if you're not already, and I will see you all in the next video.